talking about some trigonometry stuff, okay, which means we are obviously going to need our 3 original trig ratios. So let's just put those right at the top of our paper because we're going to need to reference those in a little bit, okay? So we know our 3 originals, sine, cosine, and tangent, okay, which gives us SOHCAHTOA. Our ratios that always go with those guys. Hi, Jasmine. Okay, no, just go ahead and sit anywhere. Alrighty, okay, so we're gonna need those. We know that we need those, the 3 original functions. Okay, so for numbers 1 through 6, those are gonna help us. For numbers 1 through 3, these are just our originals. For number 1, what are we trying to find? What function are we talking about? Sine, cosine, or tangent for number 1?
Tangent.
Tangent, good job. Okay, so we need to find the tangent of theta, which means we're standing at theta. Okay, what 2 sides do I need for tangent? Think TOA.
The bottom and then the right.
We need opposite, yes. Which do we not have?
Wait, the right, yeah. So right there.
Gives us the hypotenuse. We don't technically need the hypotenuse for tangent. We do need that adjacent, which means we're going to have to find that missing side. How do we find the missing side of a right triangle? What theorem are we talking about? It starts with a P.
Pythagorean.
Pythagorean theorem.
Oh,
Beautiful.
I did not say that right, but you know,
Close enough.
There.
A squared plus B squared equals C squared. This is how we got to find that adjacent side. Okay, so remember our 2 legs of the right triangle are A and B. I'm just going to go ahead and say 7 is A, our adjacent side is B, and then 25, our hypotenuse has to be C. Okay, so let's just plug in what we know / what we don't know. A is 7, so 7 squared. B we don't know, so we're just going to keep it B, plus B squared. C is 25, 25 squared. All right, well, you guys know to just get rid of the squares where we can. What I mean by that is, what is 7 squared?
49.
49. Okay, can't square B because we don't know what it is. What about 25 squared?
625.
625. Cool. Okay, now it just becomes an equation. We're trying to get B by itself. Okay, what do I need to do, or what do I need to get rid of first? The 49 or the squared?
49.
49. How do we get rid of it?
49 on both sides.
Look at you guys go. So I have B squared equals 625 minus 49?
576.
576. And lastly, how do I get rid of that square that's attached with B? Boom. Guys are so good.
1/5.
And B, the square root of 576?
24.
24. Nice.
Look, see, this is 3 days in a row that I've actually been talking.
I know, you are like hyped right now and I love it. I love it.
I was gonna say it.
Okay, so our missing side was 24, which is great. That right there is the hardest part of what we're doing. Finding the missing side of the triangle, which you guys already know how to do. That's like a little freshman skill, Pythagorean theorem. Okay, now that we have our opposite and adjacent, well, now we can easily say what tangent of theta is. Tangent of theta equals opposite over adjacent, 7 over 24. Last thing you always want to check and see if you can reduce. Can we divide 7 and 24 by anything?
No.
Nah. So we're reduced. 7 over 24. Boom. Okay. Awesome job. So on your assignment, you might have to solve for a missing side of a triangle. That's okay. You know how to do that. Okay, let's look at number 2. It wants us to find sine of theta. What 2 sides do I need for sine? Think SOHCAHTOA.
We need opposite and hypotenuse.
Beautiful. What 2 sides is it giving me?
20 and 60.
It would be nothing on the bottom.
Yep.
And then it would be
16 and 20.
Yes. What are those guys? Opposite, hypotenuse, adjacent?
20 would be hypotenuse.
Check.
Bottom would be opposite, or, oh wait,
adjacent.
Wait, why?
And 16
Wait.
will be the.
Oh, yeah, because that's the one that's.
Yep, so on
Okay,
the
yeah.
opposite side. Beautiful. Do we need to solve for any missing sides here? Or do we have everything we need? We have everything we need, right? It wants sine, which means I need opposite and hypotenuse. We have that. Okay, so the sine of theta equals opposite 16 over hypotenuse 20. Okay, now, why would your computer mark you wrong for putting in 16 over 20?
Not reduced.
It's not reduced. What can we divide both 16 and 20 by to reduce it?
3. And the 2.
We could divide 2. Anything bigger than 2?
5.
4. Nice. Okay, let's do it. Let's divide both of these guys by 4, which is going to give us the sine of theta.
4 over 5.
You got it. And look at that. 4 over 5. Beautiful. Nice. Okay, so sometimes you might have to solve for that missing side. Sometimes you might have to reduce the fraction. You guys know how to do all of that. Okay, last guy, cosine of theta, which means we are standing at theta right here. What two sides do we need with cosine? So, ka, toa. What two sides do we need with cosine?
So,
Look back up here.
A hypotenuse and adjacent.
Good. Okay, what two sides did it give me?
opposite.
Opposite.
Did it give me the opposite?
Hypotenuse.
It gave that no. So, and then adjacent.
Good job. Which means, do we need to solve for any missing sides on the triangle here?
Yeah.
No.
Why?
No, we need cosine. Wants cosine, which means the only two sides we need are adjacent and hypotenuse.
Yeah.
So boom, we already got it. We're good to go. So we can say the cosine of theta equals adjacent 12 over hypotenuse 20. Okay, would it mark you right or wrong on this guy?
Wrong.
Why?
Reduce.
Gotta reduce it. What do you want to divide it by? 2.
6.
I don't think 6 will go into 20.
No, no.
Oh, you're answering it.
Yeah.
12.
6 and
Oh, wait a second. Oh,
6
yes.
and 10, yeah.
Yes. Ooh.
Well, it can be.
then you can reduce it again.
Which will-
How?
With 2.
With 2 again. Okay.
With 2 again, yes.
Which is going to give us a final answer of what?
3 and 5. 3 over
Job.
5, which is a lot better.
Boom. Now it would mark you right. Fully reduced. Great job. Alrighty. Okay, so those were our original trigonometric functions, sine, cosine, tangent. They just correlate directly with SO, CA, TOA. Okay, now with our not inverses, that's the wrong word actually, the reciprocal functions. In fact, turn your paper over really quick. I want to make sure these notes are rock solid for your test on Thursday.
I lost those notes, so I need these again because I don't
Good.
know where it went.
If you just have this paper, I want to make sure you're as prepared as possible. Okay, so we know that our 3 original functions were sine, cosine, and tangent. Okay? Think every one of those is over 1. Technically, it is a fraction. There's an invisible 1 on bottom. Okay, what is the reciprocal name, the fancy math name, for the reciprocal of sine?
Would be C.
It would be CSC.
Good job. Which we call cosecant. That's the whole name. It abbreviates to CSC.
C, and then the second one would be CO2. Yeah. T, not 2.
We'll get there. We'll get there. Okay, but remember, this is just 1 over sine. Okay, because we will have to use this in our calculator. So cosecant really is just 1 over sine. Okay?
CO2.
CO2. I think that's like a gas or something.
That's
Carbon dioxide.
it's yeah. I meant to say T, but I kept wanting
I
to
love
say
it.
2, and I
I
was
love
like,
it.
wait, hold on.
Did you have science earlier?
Yeah.
Alrighty.
Me too.
Okay, what is the reciprocal of cosine? It's either secant, cosecant, or cotangent.
Cotangent.
It is secant. Okay, which abbreviates to SEC. Which again, it's really just 1 divided by cosine. That's what that means. You've flipped it over. Okay, and our last reciprocal, like I said, this one like makes the most sense in my head.
Cotangent.
Yeah. The reciprocal of tangent is cotangent, which we abbreviate with COT, which is really just
CO2.
CO2, yep. Which is really just 1 divided by tangent.
Okay.
Okay, awesome job. So flip your paper back over. Okay, because on numbers 4, 5, and 6, now we need to find the reciprocal function. So let's look at 4. Okay, it's asking for secant. What was the original of secant? Look back on your paper, the back of your paper.
It's
Cosine.
cosine, yeah. So then the square root of 13 would be the hypotenuse.
Beautiful.
And then 2 would be adjacent. So then you can just go ahead and
Yeah.
from there you don't have to do anything else.
Boom, Bella's got it, okay? The original was cosine, okay, which means we need adjacent and hypotenuse, so katoa. It gave us adjacent and hypotenuse. Yay, thank heavens, we don't have to solve for a missing side. So we can go ahead and just find the cosine, flip it over. Okay, the cosine of theta equals adjacent to over root 13. So what is secant of theta going to be? Flip it over.
Oh, whoops.
Also, root 13 over 2.
It's 13 over.
You got it. Root 13 over 2. And make sure you do not forget that root 13 on your computer. But there we go. Secant of theta.
Oh, that's right. With these ones, you don't have to reduce it.
Nah, because the little root, the square root of 13 is a much different number than 13.
Yeah, that's right.
Okay?
CSC.
Alrighty.
Cosecant.
Cosecant. What was the original of
Sine.
cosecant? Got it.
Sine.
Boom.
So then 17 would be the opposite, and then 19 would be the hypotenuse.
Ooh, what 2 sides do we need for sine?
You need the.
17 and.
No, you have it. That's right.
I have
That's the
everything,
same.
right? I need opposite and hypotenuse for sine. I have everything I need. So I don't need to solve for any missing sides of my triangle. Okay, I can just go and find the sine of theta. It's going to be opposite 17 over my hypotenuse 19. So somebody tell me, what is the cosecant?
19, 17 over 19.
Boom.
And then that's the answer.
Boom. Just
Oh,
flip it
whoops,
over.
Wait.
I knew what you were saying.
Oh, I flipped. Wait.
I think you flipped
Oh,
too
I flipped
prematurely.
them. I was looking at 2 different things. Uno momento. Por favor.
Beautiful.
But that's good.
Okay, our last reciprocal function, finding the cotangent. What was the original of cotangent?
Tangent.
Tangent.
8 would be the adjacent.
A 10 will be upon.
Yeah. Ooh, wait a second. Darn it, darn it, darn it. What side do we need for tangent? What 2 sides do we need for tangent?
Opposite.
Opposite.
Ah,
adjacent.
darn it. We don't have the opposite.
Already.
That's okay. You guys know how to solve for a missing side. Let's go ahead and make 8 our A, right? Because we got to plug this into Pythagorean theorem. Opposite will be our B. We don't know B. Hypotenuse always has to be your C. Okay, here we go. This is good practice. A squared, so 8 squared, plus B squared, don't know B, equals C squared, 10 squared.
64.
8 squared
plus C
turns.
squared plus 100.
You got
I
it.
don't know why I looked that up.
Okay, so just got rid of my squareds. 8 squared is 64. Don't know what B is, so I can't get rid of the squared there. 10 squared, 100.
Minus 64 on both sides.
Love it. Got to try and get B by itself, so we're just subtracting that 64.
It will be 36.
Bada bing, bada boom. And how do I get rid of the squared?
Square root of.
Boom. You guys are like flying.
Square root.
What is my missing side?
6 is 6.
Cool. Now I have both the sides that I need. I have my opposite and adjacent side. Okay, so first to find the cotangent, let's find the tangent. Okay, so tangent of theta is opposite 6 over adjacent 8. What is cotangent of theta?
It's going to be 8 over 6.
Can we reduce 8 over 6?
Yes.
What can we divide both them by?
2.
Which is going to give us?
Wait, what?
Can we reduce 8 over 6?
2.
Uh-huh, we can divide both of them by 2. 8 divided by 2 is?
8 and 3. No, 4 and 3.
There we go.
I said it wrong.
Final answer, cotangent of theta, 4 over 3. Whoa, look at all that work, you guys.
Okay.
Boom. Show me a fist of 5 on finding the ratios with all 6 functions. The 3 originals, the 3 OGs, and their reciprocals. How you feeling?
I just get things flipped up, but for the most part, I got it.
Cool. Alrighty. Okay, here's what you're gonna need for our next 2. You're gonna want the back of your paper right here. You're gonna wanna look at this nice, pretty unit circle that I'm not even requiring that you fill out. It has all the information given to you. Okay, so for number 7, it's asking us to find the cosine of theta. Okay, that means this angle right here. Okay, the little arrow that's making our angle right there of theta. Okay, so there's theta. What you guys will notice is it's giving us -60. Okay, so turn your paper over and look at your unit circle. Okay, and let me zoom out here for a second on the video. Okay, so look at your unit circle here. And notice that it goes counterclockwise if we're going positive. Okay, well, let's say we start here at 0 and we go -60 degrees. That means I'm going to land at, how many degrees did I just land at?
300.
300. Okay, so this actually isn't too bad. You just needed to know which way you went. So really, I'm standing here on the circle at 300 degrees. -60 is the same as positive 300 on our circle. Okay, it wants the cosine of theta. Make this note on the back of your paper. Okay, this was super important. You are given coordinate points. The x part of the coordinate point, or the one that comes first, is your cosine. The one that comes second is your sine. And if it ever wants tangent in referencing the unit circle, then it wants you to divide sine by cosine. Okay. It's a lot of information and it looks way more complicated than it actually is with all the pi's and all the square roots and everything. Okay, here's what we really are looking at. Okay, so I'm standing right here at 300 degrees. It wants the cosine. So I just want that very first coordinate point. What is the cosine of 300 degrees or -60? That's literally it. It's just 1/2. Yep. So the cosine of theta of -60, which was actually 300 degrees, was 1/2.
That's the answer.
That is literally the answer. So all you're doing on these 2 are just looking at your unit circles and finding where are you standing on the circle, what part of my coordinate point do I need. Okay, so let's see if we can find tangent, tangent of 135. Let's look at our unit circle. Okay, I start at 0.
At 120.
Ooh, wait a second. It told me positive 135, so that's nice. I know I'm just standing at positive 135.
Oh.
So 3 pi over 4?
Negative.
Ooh, but we want these guys. We want sine divided by cosine.
So it would be, the answer would be 3 pi over 4?
Ooh, you guys are about ready to blow your minds, okay? So remember, when it wants tangent, we're taking our sine, our second coordinate point, dividing it by our first coordinate point. And you're like, are you serious, Miss Campbell? I'm like, yeah, let's do this. Okay, here we go. So go back to the front of your paper. We are gonna take square root of 2 over 2. It's actually gonna be so much nicer than you think it is. Promise you. when we divide by a fraction, you guys, what we're actually doing, if you remember way back in elementary school, is multiplying by its reciprocal. So square root of 2 over 2 divided by, which really means times by its reciprocal, 2 over negative root 2. Okay? Just took those two coordinate points, the sine and the cosine, we're dividing them. Which really means we're multiplying by the reciprocal. Okay, you guys, what is that really awesome rule in math where if it's the same thing on top and bottom, what does it turn into?
A positive?
It is the same
One.
thing.
It turns into a 1, right? 2 divided by 2 is 1. Root 2 divided by root 2 is also 1. All we have to account for here is the little negative sign. So our final answer here is just negative 1. Whoa.
So
I will tell you on your review and on your test, there won't be any questions that are quite that complex. So if you're stressing right now with numbers 7 and 8, relax a little bit. Alrighty, cool, you guys. Last two examples. This is where we are dealing with finding a missing angle, okay? It wants us to find the measure of angle C, which means we'll just mark it with an X. We don't know what angle C is. We need to find it, okay? Well, how in the heck are we going to do that? Turn your paper over. We need to talk about what we talked about last time in class. Okay, the little formula that's going to help us here is called the law of sines. If you remember from last time.
Oh yeah, the law of sines.
The law of sines. It sounds like super like, here's
And
the
then
law.
The law of sines is the stop sign.
Yeah, exactly. Okay, so the law of sines, it's basically a ratio. The sine of angle A over its side A is proportional or equal to the sine of angle B over its side B. That's also proportional to the sine of angle C over its side C.
Right.
Okay, it's just a formula, okay? All we have to do is identify where my angles and where my sides are gonna plug into this formula. Okay, so let's turn the paper back over. Okay, so I am given angle A, I know, right? I know 96, my angle A. I also know its corresponding side, which is side A, little a. I don't know angle C, that's what we're trying to find, but I do know its corresponding side C, which is all we need to set up the equation. So here we go. Sine of angle A, 96, over its side, 34, equals sine of C, which we don't know, so we're just going to call it sine of C, divided by its side, 15. Okay, now this looks really complicated, but really this is a two-step equation, meaning there are two things you got to do to get C all by itself. The only thing that's complicated is the little buttons you press in your calculator. Okay, so look at our side with our C. Which is farthest from the C? Which do I need to get rid of first, the sine or the 15?
15.
Good job. What's the opposite of divide by 15?
Multiply by 15.
Boom. There's our first step. Boom. Okay, so on this side, in fact, I'm going to write this whole thing out. 15 times sine of 96 divided by 34 equals sine of C. It's a little prettier when I write it all out. Okay, don't combine anything over there. Just leave that how it looks. How in the world do I get rid of sine? What is the opposite of sine?
Tangent?
No, no,
Tangent? Oh, opposite.
no. There's a little button right above sine. It has sine -1 on it. It literally means the inverse sine. That's how we get rid of sine. The opposite of sine is the opposite of sine. Yes. Not a trick question. So here's what we need to press in our calculator. You're going to take the inverse sine of this entire thing. Okay, let's practice punching it in together. Okay, so here we go. You're going to want to click your second button first because you don't want original sine, you want inverse sine. Okay, 15 times sine of 96. Close that little parenthesis there. Divide it by 34. Close the whole thing parenthesis. And we get our angle measure. How many degrees is angle C? Let's just round it to 1 decimal place.
So it's gonna be 26.0.
You got it. So the measure of angle C is 26.0 degrees.
So it's 26 degrees.
Yep, 26 degrees. You got it.
Whoa.
Boom. Okay, so like I said, just setting it up is kind of the tough part. Doing the opposites, that's not too bad. The opposite of divide by 15 is times. The opposite of sine is the opposite of sine. Boom, then you just gotta punch it in your calculator. Okay, instead of example 10, I want to change that one up a little bit. Okay, I'm gonna get rid of that example and I'm gonna do some really easy ones, okay? But I know they're gonna be on your assignment and test, so I just wanna go over them. Okay, so let's say it wants to give us find the sine of 56, find the sine of 960, and I'll just switch it up, find the cosine of, what do we think, 135. Okay, there will be questions like this on your assignment and your review. All you need to do with these guys is grab your calculator. Make sure you see the little DEG mode right here. Okay? And then we're just going to type these numbers in. Okay, so first it wants the sine of 56. Sine of 56. Enter. Okay, let's practice doing some rounding here. I want it rounded to 4 decimal places, which means 1, 2, 3, 4. I gotta look at the 5th one. What
So
is this gonna round to?
0.8290.
You got it. 0.8290. Booyah. Okay, let's do the next one. Sine of 960. Sine 960, parentheses, equals, ooh. Okay, let's practice rounding to, give me 2 decimal places, just for practice.
Negative 0.9.
Ooh, 2 decimal places.
Oh, negative 0.87.
Good job. Beautiful. And my last guy, cosine of 135. Ooh, okay, let's practice rounding to 2 decimal places again.
Negative 0.71.
Boom. Boom, Kaylee, boom. And there we go. Okay, so some of them you just need to enter it simply into a calculator.